So when do you want to take the picture?
I think right before our break.
Okay.
Because usually in the beginning, the students still coming.
It's okay. It's okay.
Yeah.
It's
Because it seems it's still 28. It should be around 50 actually. So because here in Indonesia, we are still in Maghrib praying time. So probably they are still praying for about 5 more or 10 minutes. But you can start if you would like to start the session.
Okay. Okay. Now let's begin tonight's course. And I will share my screen just a moment. And first of all, let's take a short review what we taught to you last week. Last week we're talking about actually it's an entry level for the machine learning. So I think from now on we'll deal with some data sets. Some are maybe small, some may be large. Most of the time, I hope all of you will be familiar with the technique just in this lesson. And this time we're talking about moving average, simple and multiple regression. So tonight, I think we'll launch this models by Python, and we also provide with data set. And of course, I also leave some space with some room for you. You can practice, and you can try to build your model, modify the model that I give you, and maybe you still meet your needs. You will develop later. So let's take a very short review about what we taught last week. We're talking about five forecasting, right? And the forecasting are already wrong. And we tell you some forecasting model. And one interesting model is about the quantitative forecasting model. And I hope you remember about the Delphi method. You can use the consensus by looking some questionnaire again and again to focus on the topic that you want to talk. And so tonight we are moving on. We are talking about the moving average, and we are talking about simple and multiple regression. And some advanced topics, for example, I'll give some room for you. Maybe you can try to modify or improve my model. Now I will give you. And this is time series forecasting. Okay. For example, if you look into the statistical data of commodity or anything like sales, if from year to year, you can find a very similar pattern. So sometimes, for example, if you look into this chart, I think the busy season is about you can see about the one, right? The first season, and I think the low demand is maybe uh, falling down the third and the fourth season. So most of the data you can find a trend like this. So we can just look like this. So this one. So the data actually you can describe it by three elements. Okay. The one could be level. The second could be trend. And the third could be seasonal. Seasonal. And of course, combine these three factors, you can build a very complicated model, like a winter model. But in prediction, you must have one sense about that, not the complicated model always perform the best prediction. Sometimes the simple is best, in my opinion. And in most of business, actually, they love to use the simple one rather than the complicated model. So tonight, I think I will show some simple model. Okay. This is also you can check. For example, from 1998 2001, this data actually are the data. Okay, they are the same data. Sometimes, why I present these two slides? Sometimes if you didn't visualize your data, actually maybe you didn't really recognize you have level trend or seasonal. Okay, but once you transform your numerical data to graphical data, it's called as a visualization. Actually, maybe some idea will come to your mind, so you can choose the appropriate model. And okay, now later I think I will give you these three models. Okay, the first one is simple moving average. Simple moving average. That means you can have the first, for example, first n data from 1 to n, and after that, you give a mean for this data divided by the size that you expected. Sometimes maybe this is not easy to see from the formula. Just a moment. I use Excel. Actually, it's more easier to understand. Okay, I open Excel and use a simple example. Okay. For example, I can show you my time, and the other one is the quantity. Maybe it's your sales. It's your company, you sell some commodity. And for example, if I give you 10 examples, so it says, and that is your quantity sales for each time period. Okay. These are assumed data. So when we talk about the moving average, for example, if I take a three period, that means actually you can take this 1 and 2 forecast. Of course, what does that mean? For example, you can use this one. Actually, this is quite a simple. If you have an Excel, you just copy your formula like this. We can use the average with this. And what do you want? You want to average, for example, from the first to the third, right? So there corresponding about the block is about the B2 to B4. So you can take okay. So you'll give you a forecast value like this. After that, you just and drag now. Okay, so you can see all the values. Because how this 180 comes from? Because you use this one. You plus 3 numbers, add in 3 numbers, 250, 150, and 140 altogether. Okay, after that, let's divide it by 3. Again, and again. So this is the simplest idea about moving average. Of course, if the data size is bigger, maybe you can use 4, 10 more, right? And when we go back to see this formula. Oh, it's PDF. So when you go back to see the formula, so now you can see if you use 3, that means you take the previous, okay, the previous 3 data from 3 periods and give the mean to this data. So I just show you the n equals to 3. And of course, n could be equal to any number that you prefer. This is simple moving average. And now let's check the second one. What is the weighted moving average? This model we can see briefly written as SMA. Okay, just take it there first later. And this one later we will describe by WMA. Also, we use the first letter. And you can see now we have different weighting to the data for each time period. Here, W1 is the weigh-in, okay, or you can call it the weight for the first period. W2 is the weight or weigh-in for the second period. Okay, and again, if I take a 3 weights, if I consider only 3 weights, and n equals to 3, then we go back to there and show you the second one. Okay, here is the simple forecast. I call it the simple moving average. Okay, now we use the weigh-in. Okay, we use the weigh-in and how to compute this. You want to see the detail. You see the weighted moving average. And this one, again, we also computed from the first and the fourth period. But here is the difference. Let's see. Because you give the weight, right? So you must arbitrage or you must subjectively to given the weight for each period. And the sum of this weight should be 1. So for example, I weigh in the first period data by 0.5. And it comes from this one, D2, okay, D2. And the second, I weigh it by 0.3. And it comes D3. And the last one, okay, the third data, I weigh it by 0.2. Okay, so we'll modify the formula, the new one. Okay, please ensure your weight, the sum of your weight should be 1. And you also give obtain a number, right? This is the forecast. So it's different. You can see it's different. So now again, I can copy. Okay, I can copy and drag down. And you can see all the values. Okay, all this value. Of course, different forecasting model generate different output. Okay, and which one is best? Is best, or which one is better? Actually, it could be compared with that is the idea about error. So I think I can notice the error concept first. Error. Okay. And what is the error? Actually, it's the prediction value minus the actual value. For example, if you put the WFA, right? WMA, okay, the one. The other one I said is error of SMA. So you can simply check here. I say you can use prediction. For example, is C4 and minus C4. No, so D2, sorry. It's D4. Okay. So this is actual equity value. This should be the T5. They must be identifying the same route. T5, okay, and minus T5. Yes, that's right. So you get an error. You can check, right? Your prediction is more than the actual value, more than 50. And of course, you can also copy. Check now. Okay, so these are the error you can see. Okay, over and less length, less length, less length, less length. And of course, here you can did the same thing. Did the same thing. So here from here is the prediction is B5, right? And minus also B5. Okay. Then you get another error. Okay. And again. Okay. So these are the but generally speaking, when you compare these two, right? When you compare these two errors, it looks like that this may be smaller, but you must compute. Like some, I will tell you about the detail later. This looks maybe far beyond the actual value. Like but SMA looks maybe better, maybe better. And the error term, there could be various definitions. We'll talk about this in detail later. Okay, so I hope that you understand on the moving average, the basic fundamental of moving average. And now let's go. Here. And what is its potential moving average? Actually, its potential moving average. Actually, you must have given a sense. Yeah. Okay. How many? How many you try to? Okay, and you must given this actually is like a alpha value, and I show you. So you must give it limit to 1. Okay. So show you the this is called exponential smoothing. Exponential smoothing. You can easily find. The I will talk to you years about formula. Let's see the formula. Okay. The formula like this, because the predict value is referred by what? Yeah, by the current. Okay, the current actual value and the previous prediction value. S is prediction value. Okay, S is prediction value. So when you see the alpha, actually alpha means the P, the percent. Okay, so alpha must value to 1 is much between 0 to 1. So actually, when you rearrange this function, okay, rearrange this function, and you can see this function will be the same like this, okay, this one. If you rearrange the function, And the time span also means how much period you want to refer. Okay, and in this case, okay, in this case we can go back to check. Okay, if you use, okay, I also use the Excel for the first time for explanation, so you are more, it's more easier for you to understand the scale competition inside. Okay, so I write an explanation solution here. Take it and according to, the first time you type in the formula, maybe consume some time, but after that, will be very fast. Take a look. Sorry, look at more, much easier. Yes, this one. Okay. Yeah. The first one, you can see, it just copy the actual value, right? The 0 period. Okay. So you can give a so now I must insert one new route because we have the value for the period 0. Sorry. Yeah. Okay. So this is period 0, right? Yeah. Exponential smoothing here. And now exponential smoothing. So he say the x0 must be the 1. So this is 0, right? So the 0 actually we have many ways to generate the value. You can use the f as the mean of all this data and say it's the 0. It's okay. Also, you can use the first one as 0. Okay. So there are many different ways to define. So let's look here. In this case, I use the average as the 0 value. Okay. Actually, it's depending on your assumption. So now I use 1. Okay. Here is the mean of the actual value. So here from D3 to D12. So you got a value 231. Okay. Now I use this one as x0. Okay. Then after that, you can see now you want to predict the first one. You can use according to the formula. You must decide an alpha. Alpha is larger than 0 and less than 1. Okay. And so S1 you can see alpha multiply x1 plus 1 minus alpha and x0. Can you see that? Right. So after that, you just because you type in the function in the first time, after that you can use copy. So Excel will also descend or ascend by your order. So let's see the first one. F1 is here. If I choose alpha equals to 0.5, So you have to do like this. Five, right? And on 100. Now, please use the plus notation. So this is plus, right? 1 on 0.5 and plus S0. And the S0 you just got is 231. 231. So actually, because you want to the equation to descend or ascend, such a case, you must iteration. From each iteration is auto numbered, so you can use E2, okay, E2, because E2 means S0, right? 0. So yeah, you got the first one like this. And after that, you can also copy. Yeah, copy, okay? Drop down. So you can see another model explanation generate different models. But in such a case, don't know. Yeah, and because you must check the error again to see this model which performs better, okay, and which is the best in such a time series data. Later, I will show all of the steps in Python, okay? And what we trying to do is to predict the Bitcoin value. Yeah. And so far, if anyone has any question about the detailed computation? Okay, if you know, I go further, okay, go further. Now let's take a look. Okay, all the steps now I present here will translate into the Google Drive collab, okay, collab. And I think in such program, I will show you step by step, okay, and to see how we can load a data to download data in a very short time and to fit this data into this model. And of course, after that, you must be able to draw the figure like this, goes according to this time series. Okay, so please, and I give you 3 minutes. Okay, I give you each of you 3 minutes. Please kindly to download the link I provide here. I share a Python notebook for each of you. So you just click. You need to the Python. Yes, just like this. Okay. Before I share one of you, so please try. Now I'll explain the code section by section. Okay. It looks more clear, right? More simple. please, okay, please take your time to download this Python notebook. Okay, we will start within 1 minute. In this program, I think you will learn about how to interact with Y finance. That means you can download many financial data up to date. Use this data to predict. Predict actually why you make a prediction for this financial data. Because you know, in financial management, it's really important to decide the time when you want to sell, okay, or buy a stock, right, or some fund. So prediction actually is very important in financial analytics. Okay, now let's look at this program. Here's the first one. You can see install what Y finance. So I must explain what is Y finance. Let's take a look. Y finance, you can download, okay, download the market data from Yahoo Finance. So enjoy. If you are really like to predict something, so you can see. So many. Here's many examples here. You want to try. I will show you say or the company name. For example, it's Google, right? It's Apple. And they use short name, so you must know what is the real name. Okay, the real name. In short, so many. Okay, so you download the market data. After that, you can use. Okay, and the second, you use data as web. You import Panda data reader data as web. What does this mean? You try to retrieve the data from the web. Okay, so you import this library. Yeah. At the same time, you also daytime. Daytime is really important because the time you can see how this value change from time to time. So you import the library daytime. After that, did you remember Panda? If you didn't remember, please go back to my previous slide. I'm talking about Panda. It's not the animal. It's a data frame. It's a data frame. So import Pandas as PD now. So you import a data frame. Now. You set the option, right? Display mark column none, and the set option display mark column now. So that means you didn't need to display all the columns all around. Okay, the next one. Now you import from the Pandas data reader. So that means this is important. please take a look at this one. Now you take the data from where? From the web, okay? Because you use this one. Yeah. Now you use this one, you import data and call this the PTR, this short, okay? Okay, now you use this one, finance, okay? USYS. And what does this mean? Why PTR override? That means if anyone that is version is available, okay, will test and override the old one. And you can see because these are old, actually you can delete this one later. You can delete this one. These are old programming code, older programming code. So sometimes maybe they are not available. They are not available. So, but this one is okay. This one is okay. So you get a data Yahoo, and what do you want to try? You try to find the data Bitcoin, right? Bitcoin. Bitcoin in USD dollars start that time because you already imported daytime level, so you can use daytime. The daytime from what time? From what time? From 200 this year, right? From the first day of this year, and sorry, maybe my name is safe to close this one, right? Okay. My mouse is too sensitive. Sorry. And well, you can, if you have the program, you can check, right? What time? From the first day of this year until today. So today is 28th February. And what do you want to catch close? I want to know the close price. Okay. So this command will get the web data, starting time and ending time. And okay, after that you can print to see what you. And after that, I hope please set all this data to CSV. I explained about the CSV format, right? It's a separated text file and separated by comma. And after that, please insert the text because I want to insert the text. Okay? And after this, I hope this is the size of the future. Later you can try. Okay. Yeah. One is a tall, and the other one is about the width. Okay, the height and the width. And please, I say please give the first 49 and 50, 50, because you know 0 to 49. Remember. Because in Python indexing is from 0, right? And 50 will be ignored. So it starts from 0 and ends at the 49, 50 data. That's the first 50 data. And because you index what? You index state. So this is state. And this is the close price. Okay, close price. And show. Okay, show the figure. And I want you to see. Okay, okay, so far. Now let's try from 1 to 1. Stop. Okay. Yeah, okay. And import library. Okay. And import data frame. Okay. And please download the data that I want. Okay. Complete. You can see right 100 complete. And after that, now I want to see what the data. What is the data? Okay. So you can see, right? Green. And do you remember we also teach you about this command? So you can press it. Do you remember that? Oh. Let's go to chat. It's okay. You can also try this one. Okay. If you are interested in the how to use the header, you can go back to my previous slide. Okay. A printer, that means all the data will be comes out. All the data, all the data. And header means a first hand. Means the first hand. Okay. So how many data you have? Okay. Here. Okay. To the latest data. Yesterday. Okay. After that, set to this file. Okay. So this command means to set to this file. And again, I redefine, read from this file and index. So this is data. You can now check all the data. Okay, after that, now we go here. This the moving average. Okay, this section is the moving average. So you can see we import looking like the numerical operation of Python and NP. And how many periods you want to refer? 5 periods. That you will get the mean from the previous 5 periods. Okay, you'll get a mean from the previous 5 periods. So here's one, SMA. So you must drop, you must transmit 2 parameters. Okay, one is window size, and the other one is about what is the data you want to proceed. Okay, you want to handle. So you must transmit 2 parameters. So if you remember, we call in Python, this is a function. A function of return moving average. So this is function, this is fine. You want to start this function, you must give it 2 parameters. Okay, one is the time period, the other is the period, the end period that you want to refer. Okay. In the beginning, I set I equal to 0. Then I define a moving average is an array. You remember this? Array, empty. And this is the loop. This is loop. Okay. Once I is less than and the number of elements in V and the minus and plus 1. That means if the element in V is not totally enumerated, then I think that the following it will continue. Okay, it will continue. And again, window is a part of V. What does this mean here? Because V, what is V? V is the closed data here. Here. V is the closed data. And window average is run. What is run? Actually, this is the function to launch this function with n equals 5. Equals 5. So this is 1. We check this equation again. Okay. We recall this. Actually, this part is compute this formula by n equals to 5. N equals 5. And we go back. And again, okay. And round means actually it's takes a 2 more numbers after the decimal point. Okay, two more after the decimal point. Okay. So if you, for example, if you take this value, for example, if you value compute here is 9.875, then it will return 9.87 and the deleting 5. And again, right? Again, and this is the 5. Okay. If the window size, then you refer the previous 20 data, will come 20 data. So, okay, very fast. And after you compute this one, you can redraw your figure again. You get this. You can see, get this. So you can compare this to figure. A little different, right? Yeah, a little different. Okay. I think I will keep going. And after that, I think I give you 10 minutes. Okay. 10 minutes during a middle break. And the second one, I call it about the weighting, weightage, moving average. Okay, 1, 2, 3. Okay. Look out here. Okay. This one. Now the second is this one. Okay. So now I use N3. So only 3 weights I need to assign. A1, W1, W2, and W3. Okay, W1, W2, and W3. So we can, yeah, right. So I give 3 weights. And the sum of this weight equals to 1, right? Equal to 1. So again, this is same. Okay, but different here. We check this one. Different here. This window, I use this weight multiply the first array, right? And this the second array. You can see I assign different weights to 3 different periods. Oh, this one you can check this one. Okay, and the return. Okay, return again. Now run this program and you'll get this date. Later you can try different ways if you want. Okay, and after that, of course, you can draw this output as a figure. Okay, and you got this figure. You got this figure. And the last one is the moving average. Okay, it's the moving average. And in such a case, okay, moving average is in such a case, I use, okay, I use 10. That's what does this mean? I use 10, okay, and I use 10 means this formula. Here, I use n equals to 10, okay, n equals to 10, and so you can also compute. I show all the data. After that, again, you can print out the prediction as the figure. As for the exponential smoothing method, okay, or you call it the exponential smoothing method. You can see, you can see, you can, I think you can compare these two figures more close. This one and this one. You can see this more peak point. Sometimes it's upward, sometimes downward, more peak point. But when you look into the smooth exponential smoothing, yeah, it's like a more smooth, right? Yeah, more flat, more smooth. Okay, and finally, this mean squared error. Okay. What is mean squared error? Did you remember how to compute the error? I just showed in Excel. The error sometimes is positive, sometimes is negative, right? Now you try to sum, okay, each of the each square, okay, each square of the error to sum of this square, and give it is a square. Yeah, is a square root. Okay, the sum give a square root, and after that you give the error like this, and you can check this one. Okay. Okay, give me one more minute. I'll show in Excel so you'll know what it is. Because in program it's present very clearly, efficiently, but sometimes it's very simple, too simple to understand. I show you in Excel like this. For example, if I have to compute, okay, I can use this one because you already have this one, right? You already have this one, so I think just more column, and the column here I take it is square. Oh, arrow, and square arrow, and this arrow and for S and A. Okay, I only show one example. So here's I can, because you can see the arrow. Some are positive, some are negative. So I use this as this is black is H4, right? H4. I give it a power of 2. Also, it should be 86. 86. So you got the square of this number, and again you copy. Okay, so you got all the square for each arrow, and after that you give a sum. Okay, give a sum of all this arrow and give it to a square root like this. So you will give what number? The number you want to sum from 3, 4 to 310, right? Like this. Okay. Okay. That 3, 4, 3, 3, 6. So 3, 6 to 3, 12. Okay. So you got a number like this, right? And after that, you give a mean to the square of the sum. Then that is the meaning of the this one. So you see, this is the actual value. This is the exponential smoothing value. So you give later mean square error, right? So you give a square for each error, yeah, between these two values. After that, you final give a square root. And so that's what you find like this. Okay, now I think I give you may I give you 10 minutes? I want to give you 10 minutes, okay? And please try to run this program because this program I think is already explained fully about this three model. Okay, simple moving average and the weighted moving average, and finally the exponential smoothing model, three model. And of course, if anyone try to challenge, I hope you can modify, because this is not difficult. Can you try to combine all these three models, all this in a figure? Okay, yeah, because now you got three different time series from forecasting, right? And I hope you can join all these figures in one, show all these figures in one figure, okay? And this I show you, right? Can you display all the square mean error in one round by modify the Python program, the Python maybe blueprint I give to you. Okay, please go ahead and try. And later we come back about the 7:15. Okay, I give you 10 minutes to try this. Please go ahead. Of course, if you have any questions, you can also ask. Okay, let's take a short break. Okay, welcome back. Now let's take a look at what I expect you to show the comparison in the figure. Okay, take a look at this. Now I share. I share my screen to you. Okay, look. Actually, you just because you already plot. Plot means you already have a figure. You give a command to the figure, right? So you can list all the figure all together. See, like this. Like two models, the comparison between two models. So it will automatically generate different color for its forecast. Then you can give all the data in the future. And of course, I can also give the real data. Give the real data. Here, this is the real data. So you can take this one again, for example, mark this and copy. Okay, Command C, Command Control, Command C, because this is the original figure, closing price. So now we have two forecasting model with one extra data altogether, right? Like this, and yeah, like this. So I think if you see this figure very common in some financial reports or on the stock market analysis. This means different model. This is the green line, is the actual, it's the one, and exponential smoothing, like say a moving average. They have different outcomes. So just what I told you, actually the most important thing is that you must to find the point first. For example, like this, if you decide 5 points here, this is correct because all the market value still going up, and I think you'll get a fortune. But this is not good. If you buy the Bitcoin at this point, then I think you will lose some money. After that, you lose some money because going down. But if you again you buy Bitcoin at this point, hopefully good, right? Going up again. This is the real. That means you must make your decision. That's what I told you to buy or sell in advance according to this forecasting. You can choose which one you prefer. But I think it's always risky. You want to jump into this market, you must have poor preparation because the market is always risky. Financial market. Okay. Any problem? Now we go to the next forecasting model about regression. I can also use Excel as an example. Okay, the next one is regression. And there are many different. So what I just told you is this one. You can also use this one. That means you divide it by you can check the difference between two arrows and divide it by arrows. So you'll get a percentage. Okay. Those arrows divided by arrow become a percentage idea. And also use this difference. Okay. No matter what the arrow turn you use. Actually, I think that more arrow turns. There are many arrow turns subjective typically defined more than this one, more than this one. You can choose any one you like. Of course, this is very popular. I just show you. This is very popular. And each one of these arrow turns, you can develop your own by the Python program. Okay, now please also take your time to download the data set about the model. What we're going to talk about is about simple regression. It's a very simple model. Very simple model about to find the relationship between two variables. So we call it simple regression. You can use the y variable is the consequence. Sometimes it's dependent variable or response or consequence. And the x is the independent variable. Sometimes we call this a cozy variable or explanatory variable. That means what we observed from y variable is actually impacted by x variable. So what phenomenon we can often observe in the real world? For example, if you want to predict the price, right, of real estate, okay, you want to predict the price of real estate. Maybe the real estate price changes from year to year. So in such a case, you can choose x as the year, and the y is the price of the real estate. For example, square meter, right? The price per square meter, and you can build a model like this. That actually is a function model like y and function of x, y and function of x. Then when you run the simple regression, it will give you a model like this one. Okay. Y equals to the constant a plus b x. This is the year, and this is the price of the real estate. Okay, you build a simple relationship between this one, a linear relationship. Okay. And we will show you an example, okay, for better understanding about this idea. What we try to do is find a straight line, a straight line. And the straight line actually, they have a difference. For example, you can make a line like this, straight line, or a line like this, right? Or a line like this. Actually, there are many choices to decide the straight line. But the simple regression is try to find a straight line to the sum of distance to all these points. Because if I find a straight line, you can define a distance from a point to the straight line, right? There are so many points before this sample. We try to find a straight line of which minimizing the distance from all points. Okay, the distance from all points to the straight line. We try to find a straight line like this. So we try to approximate this function. So please, okay. Now here's the data set. Okay, please download. It's crazy. I'll give you an example. And here's the model. And I've already built it on CoTeaching. I can share it with you. Okay. Here. Here. Okay. You are ready? Let's start it. On the first one, again, you see, it's a very popular. This one. This one. 1, 2, 3. 1, 2, 3. And here is the new one. Sequence. Okay, sequence is the new one. It's also a Python library. We will just mention. Sequence actually is a library to visualize your statistical data. That's all. Okay. So once I import this library, that means I try to visualize the data, and I can choose some library to to um, to draw a figure for my collect data. So this is called Sequence. And learn. Okay. SKLEAR. Learn. This is the big data training model. It's dynamic. So use this one. Actually, you can simply to define, for example, regression model, classification model, clustering model, or even later we'll talk you about clustering. So with this library, you can simply define the data plan for your model, the important parameter in algorithm. So like for example, how many clusters you want, or what is the optimization method you want to use, okay, and how you will split your data into training set and validation set, okay, something like that. So this is very popular. This is one. Yeah. Learn, okay, Learn. It's a machine learning library in Python. Okay. Now let's take a look at the model, okay? Model simple regression. If you already download, okay, here. And this means I will plot the plot, okay? I will show the plot, show the figure in the Python notebook. And please, okay, first one, run the first section, okay? Second section, please upload your data. Please use my hyperlink to share with you. So you should have salary data. salary data .csv. Okay, it also specifies this one. Okay, so you choose this one and upload to select. Okay, then now please show. Okay, so the data. This one to show the data, and the data set describe the data set structure. What we want to do here, this has two examples. Here is the independent variable. That means this is y, okay, and this is x. I want to try the relationship between the years you are at work and the salary you are paid. I want to find a relationship between these two. This is but a simple example. So I define, okay, I define and I plot the data. I show the data and visualize your data. Experience free salary. Yes, look, let's have a straight line relationship between them, right? You can see maybe you work longer, you get much higher pay. Okay, now I try to the same. I try to on the figure size, and now I use the Seaborn instance. I use the distribution plot. The DTIP plot means distribution plot. So, okay, then I get this one. Okay, then I get this one. And after that, I read the data set between. You can see I train it to on tester size 0.2. That means 20% of the data will be used for validation. Okay, will be used for validation. Then I run the regression. Okay, run regression. And after that, and I try to find this straight line. Also, drawing a figure. So this is the point, okay? And this is the straight line that you find to calculate one. And that this means show the error, so you can see the error. Again, it means we have error, and mean as a root. So right, you can use different one error, which one you like. And the computation, actually, you can also use another way. If you like to use in Excel, actually, they can do the same thing. Different software, but they can do the same thing. For example, in Excel, I use the same data set. You can, for example, now you try to approximate a straight line function. This time I use this is x, okay, and our cells we call this y. So now I try to find a relationship between x and y. And the y, I can assume that y equals to a plus bx. Just like we told you the formulation. And you can go to the data, okay, data, and you can use here. Okay, here, okay, here's analyze. Okay, so after here is Chinese. This means regression. regression. Okay, so regression, of course, if you use the English version, you find the sample it. Okay, t-test random, okay? And you choose regression, confirm, and now it will ask you where is your y range. So you plug here, and okay, you just constantly press the left button of your mouse and X again here to here, right? Okay, and after that you can good. So you see, here what is the function you already get? You already got about this function is about this one, because now you have 10 samples, okay? And the function should like this, the coefficient, okay, coefficient. That means you got the function like this on 115.3, and okay. So this is the function you get. This is the function you. So if you want to try to predict the next one, you can go back here, because now x1 is here, right? x10 is. So if you want to predict the next period, for example, 11, 12, what is the x is? Okay, you know you wonder what you just input the x by 11 and 12, go into this function. Okay, 11 and 12, then you can get the predict value. You can get a predict value. This is the simple regression. Then now go to the final of this course, multiple regression. Okay, multiple regression. So if you now you can accept and understand the simple regression. Simple regression means you have only one X column and output one Y column, right? And what is the multiple regression? It is quite simple. Now you have two X, for example. Now time maybe goes to X2, for example. You have another, and I call it for time. You can go another one is about the price, okay? The price of the product, right? Okay. So you now to try to find the linear relationship from price and time, how they impact the sales. Okay, now you have two. For example, when you price, it's reasonable. Cheaper, you sell more, right? Cheaper, you sell more. And if the price go up, maybe you sell less. These are only assumed data. Okay, so you also get a data like this. Yeah. So now this is your data set here. So you have the first one column about the price per unit. You also have the time from year to year, and you also have the sales from year to year. Okay, quantity sold. So now you try to find a function. Actually, this function is very similar to simple. It should be right like this. Okay, be right like so you calibrate this result. You get like this. A, for example, B, X, BS1 and plus BS2. Yes. Once you launch or run a multiple regression, you will return a function like this for you. Okay. Or also a constant scalar and on two dependent variable. Basically, BS1 plus BS2. Yes, sir. Like this. Okay. You'll get a function like this. And the way you do in Excel is very similar to what I had just shown to you. Okay. So I skip this part, run just try again. Then go back to here. Here. And in the left part in Python. Okay. You also can try to use this data. This data is to predict the carbon dioxide emission from different cars. So let's try to find the relationship. It's the volume of a car, okay, of the weight of a car. Did it really impact the emission of carbon dioxide? So let's try to find a relationship. And again, okay, so you see, use the data, okay, and the data this time we use this one, our data. Open. And after that, you can run, okay, and do the prediction. So this is the prediction for you, only one value, because we already give this two variable. So let's mean multiple variable, okay, and one single y, one single y, two variable. That means the car weighs 300 kilograms, okay, and its volume is 1,300. So it predicts the output of the carbon dioxide emission is about 107. Okay, now we close the part of the delay about this one, okay? Regression and master, okay, the master regression. You can find the data here, and you can find that the program just below the simple regression in the same Python notebook. Okay, so now I finished the moving averages, simple and multiple regression. And I also appreciate your patience because you know, once we go deeper into the machine learning, actually you can find many methods are necessary, and many models are necessary, and many formulas, are shown. We still have some time, so let's take a short start for the next chapter. Okay. The next chapter, the model now is more complicated, from one-to-one. Yes, more complicated. I show you. Yes, this one. Cluster. Okay. The next chapter. Let's get forward. Cluster. What does mean cluster? I to actually cluster is very popular. Okay, it's very popular in marketing. So I think later I will use some marketing example to illustrate the idea. Once you clustering the data, what you can do for the next step. I use the figure, okay? This is the idea about cluster. I use the figure. Okay, I think I use this one. Okay, can you see this figure? This figure. And for example, okay, if you maybe you can collect some products from the market, and now you market survey maybe just take two variables. Now I use the milk. Milk is very popular, right? So that everybody maybe drink milk in the morning for breakfast. Also maybe use milk for make some coffee. And I think now let me assume the X acid is the fat, okay, is the fat of the milk, and the Y acid is the sugar, okay, the sugar, the milk sugar of the milk. Then now you can use this too because you can survey every customer in the market, right? He or she will give you a brand, and according to the brand, actually, I think you can mark these two variables in a two-dimensional plan, right? I assume the acid is the fat, okay, the fat in the milk, and the vertical Y acid is sugar, okay, sugar of the milk. So each customer, if you notice a customer in the two-dimensional plan, it means the customer preference for the milk. Okay, that's right. The customer preference for the milk. Now with this data, actually you can cluster, you can classify into some specified group. For example, you see this group, this customer, they prefer the strong, right, strong test because higher fat and higher sugar, right? So I think once you can classify this customer, actually it's in some marketing issue for better to manage the customer. And this one maybe social, okay, middle. And this, I think this two is very important. And this one, if you can classify a group like this, they prefer the high sugar and low fat. High sugar and low fat. Yeah. So, and if you thinking more, if you use some social economic variables, right, to link their preference, maybe you can find more interesting issue hidden behind, right? Why this group has significant difference? What are the background, the basic background of this customer? Who are they? And the same, I wonder, who are these people? Okay, do you use social economic variable, and the 2C the present. Okay. So this is the basic idea about cluster analysis. That means we try to classify our collect data into some specified group, and based on this specified group, we can dig in, we can to find more hidden issues behind the observation, and to find some interesting marketing issues, okay, or marketing topics. Okay, now let's go back. Okay, so now we learned the basic idea about cluster. So the next problem is how, okay, and how to do that. Okay, today's topic is clustering, and there are many ways clustering, and we are talking about two major directions. Clustering occurring, one is partition. The popular is about the K-mean, okay, and the other one is hierarchical, and the popular one is about the tree. We can use tree, use a tree structure to display your collected data into some specified group. So in cluster, I think that I will show these two algorithms and example for you. And actually, document clustering, that means you can, for example, if you make a literature review or survey, sometimes you need to document the cluster, okay? Because if you try to write an academic article, okay, or a scientific article, you must review some article, right? And to review this article, you must classify into some group, okay? And this group maybe because the issue maybe can separate to some major outline. Okay? So group is associated with your specified outline one by one. So this is documented clustering. And the clustering, you can classify into it's from the supervision two ways. One is supervised, the other way is unsupervised. The other way is unsupervised. So K-mean means supervised. Okay, K-mean means supervised. And the tree, tree is also okay, so supervised. And sometimes the data could be unsupervised because you don't have special pattern. In such a case, maybe you can use evolutionary algorithm. Also talking about this idea next time. You can use some evolutionary algorithm to generate some clusters. In such a case, it you can define it as supervised. Okay. So two ways you can use. Let's see a simple example like this. Yep. This data, okay, this data, I think they are separated perfectly. You can find 1, 2, 3 clusters. Pretty nice, okay, 2 dimensions. But you must know, sometimes your collected data may be more than 2 variables. Please recall the milk, okay, the milk for the consumer example I just told you. And sometimes maybe you have the 3 variables, right? You have 4 variables. Try to separate this customer in 2 different clusters. based on your four variables. In such a case, actually, it's not so easy to project them perfectly in the space like this. Okay, like this. So we must design some appropriate algorithm. We must prepare some appropriate algorithm to set the length. Okay, and this algorithm must be clear, defined, have objective function, and some most of the time the objective function is minimizing. You can say two criteria. Okay, two criteria. We try to uh, maximize, yeah, maximize the similarity, okay, within the same cluster. 4 points. We try to maximize the similarity within the same cluster and minimize, okay, minimize. That means we try to separate well, okay, to define, classify them well. For example, is this the center or centroid of the cluster? I hope the distance from this centroid to this centroid would be maximized. And if you look into a distance, that means the distance, okay? The similarity and distance actually is inverse. Okay, they are inverse concepts. If they are very similar, we can call their distance are very close. Okay. So minimize the distance from each point in the same cluster and maximize, okay, the distance if these 2 points are located in different clusters. I think this is the best idea for developing cluster algorithm. Okay, please remember these two criteria. The same cluster, they should be similar, as close as they can. Different clusters, they should be separated, okay, to be far away as they can. This is the basic idea. Let's design our algorithm later. Okay, I think it's almost time. So I take a break here. Okay, we'll finish this section next week, and also with the association rule. I remember right next week because these two issues are very close to marketing management. So I think I can uh, discuss these two issues together at the same time. Okay, and so let's integrate this issue together and into the next week. Next week. So any problem about today's progress? Any problem?
So student, have you tried what Prof. Chen already demonstrated to you? Do you have any problem when you try the program? I think they are okay, Prof. Chen.
Okay.
Okay, before we ended our session, we will have
Picture.
taking picture together. So
Okay.
student, please open up your camera. So this time you can see Prof. Chen face and Prof. Chen can see your face too. Okay. Devi, can you open up your camera? Kenchana, Abdul Khalik, Amalia, Diva. Okay, we will start taking the picture. 1, 2, 3. The first page. Wait a moment. Okay, second page. 1, 2, 3. The third page. 1, 2, 3. So thank you, Prof. Chen. Thank you, student, for this evening sessions. We will meet again next week. Thank you,
Yeah,
Prof. Chen,
see you next
from
week.
your time, for your knowledge that sharing to us. Have a great night, Prof. Chen.
Pleasure. Okay. So good night and see you next week. Okay.
We will see you. Oke, teman-teman, terima kasih kehadirannya malam ini.